Hello, everybody. How's it going? Hopefully you guys are hearing me okay, and welcome to the next live stream in the Network Skills series. So I'm going to go in and hopefully a lot of folks had a chance to watch my previous live stream, which was on the subnetting. So I showed you guys how to do some subnetting. And it was in my community over on the YouTube channel, Learning and Technology with Frank, where I had a lot of, well, this is the Learning and Technology with Frank YouTube channel, but on the community of the Learning and Technology with Frank YouTube channel, I asked the question, how many of you, what skill sets would you like to learn? What types of things would you like me to talk about? And networking came out as being the sort of the dominant one there. So there's cloud services, teams. I had a number of different choices there. So we'll get around to a lot of them. I'm even thinking of maybe doing another live stream, maybe during the middle of the week. So definitely comment either live if you're here, or you can comment down below if you're watching this in the future. You can comment at what sort of time frames work best for you. It's like many things, you know, the world is a big circular place, so it's very difficult to get a time zone that works for everyone. I'm mountain time in central, sort of western central Canada. So right now it is 6:05 p.m. my time, 6:06 p.m. my time, and that's sort of a good time for me. But any day of the week. Anyhow, so what I thought I would do is maybe take a step backwards. We're going to go and take a look at subnetting again. We're going to reinforce what we learned in the previous live stream, and we're going to look at subnetting a Class B as well. So hey, that's fantastic. So I just see Stephen won a Caesar ET24. That's fantastic. Yeah, so ZZUR is actually one of my sponsors on the channel. They make overhead scanners. So I have a couple of videos here on the channel where I talk about document cameras and such, and they're fantastic for that. So that makes me really happy that you won that. That's fantastic. And the ET24 is a really good one. So fantastic. So yeah, so as I was saying, in this one, we're going to talk about the OSI model. So in this live stream, we're going to go back, and the OSI model is kind of an interesting topic because, well, I think all networking topics are interesting, but I really think that the OSI model lays a scaffold or a foundation or a framework that you can use to tie all of your networking knowledge into. So the whole point of learning the OSI model is not so that you understand the model as a practical applied model, because there is actually no protocol. There's some experimental stuff, but there's no protocol that uses the OSI model in its pure form. What it does is it provides a structured approach to understanding the different elements that make up a computer network environment and understanding what happens at each of those layers. Now, this is going to make a lot more sense as we go through, as we go through the model tonight, but we're going to use this as a foundation for other live streams as well. So when I talk about, for example, subnetting, what I'm really talking about is something called TCP/IP, which stands for Transmission Control Protocol Internet Protocol. Subnetting, which is the logical division of the elements of the network into logical separate entities called hosts and networks. That's a bit of a mouthful if you're just starting to get involved in networking, but it'll make perfect sense by the time we've gone through a few different live streams here on networking. So I'm hoping to do that. And I think a lot of you, and you can again comment if this is the case, are looking to get your Network Plus certification, and maybe some of you are looking to get your CCNA certification. And I'm hoping that over the next few weeks through these live streams, that I'll provide a resource for people that are seeking to get those types of certifications, just to reinforce some of the stuff that you're doing to read and learn, and maybe explain it to you. The benefit of the live stream, of course, is that I can answer questions as we go along. So the OSI model, or the Open Systems Interconnection model, is a model that's used to divide the networking functions, or the functions of a computer system, into layers. And each of those layers will have a purpose in terms of communicating and in terms of allowing the entire system to work. So I'm going to once again pop over to the whiteboard. So we'll have the whiteboard here. So hopefully everybody can see the whiteboard. And I'll take this banner off. You guys all know that you're on Learning and Technology with Frank here. So that gives us a little bit more real estate as well. And I always, as always, because I'm working off a surface here, if I'm not looking you directly in the eye, hopefully I'm connecting with you directly in the brain. So definitely feel free to comment, and I'll try my very best to catch them as we go along. So the OSI model, what does that mean to us? And let me just grab my tablet here. It's giving me a little bit of grief, but we'll get this sorted out. There we go. Sorry, got this here. And we'll grab this here. I'm just going to reconnect my tablet here. Just make sure that my drawing is working. If not, I can just use the stylus on my... There's always something when you're live, so I'll just use the stylus on my surface here. So I can use that as well. Okay. So we'll see how we're doing with the screen here. And we have this here. So let's see if I can draw on here. And grab that in. There we go. So this is gonna work for us. Okay, we're getting a little bit of a lag here, but I'm gonna go here and change things up. Okay. There we go. Okay, so the OSI model is a layered approach to the way that systems communicate with each other. And there are 7 layers to the OSI model. And what happens is each layer connects to the layer above it and to the layer below it. So 1, 2, 3, 4, 5, 6, and 7. Now, each layer has a distinct name, and I'll give you a little bit of a trick for learning those names. So you can say, if a lot of people work from the bottom up or work from the top down, so you could say, please do not throw sausage pizza away. So that's one way to remember it. Get the S in there. And the other way that you can remember it is, a professional service technician never declines payment. So you can put that in there as well. And what we're going to take a look at here. Hello, everybody. Oh, thanks, Helmut, for putting that there, that you built an Azure there. That's fantastic. And hello, Terry Cooper. Thank you very much. Thank you for coming back. Zena, hello. And Maddie, hello. So we got a lot of awesome people here. We have some return visitors. Glad to see you guys. And again, so one-man show. I've got the chat over here. So if I don't see you right away, then you can just hit me up. Yeah, and question and answer afterwards, or if I can catch you even during the stream, you're welcome to ask questions as we go through, and I'll answer them. So to remember the different layers of the OSI model, a professional service technician never declines payment, or going from the bottom up, please do not throw sausage pizza away. But what are those actual layers? Well, what they are is, at the bottom, we have the physical layer. So we have a physical layer, and this is descriptive of the devices that connect our network together. And I'll be going into more detail in all of these. Then we have something called the data link layer. And the data link layer is a series of electronic protocols that allow me to set up framing for network communication. Then we have the network layer. And the network layer is a logical layer. And that's where we had our subnetting in the last live stream. That's network addressing. It's a logical way of identifying the various different networks and the various different logical elements on a network. Then we have the transport layer, which defines the communication between different devices on that network. Then we have the session layer, which keeps control of the different, I don't like using the term to define the term, but it's the different sessions or the different communication framework that we have there. Then we have the presentation layer. So we have the presentation layer, which allows me to have different presentation protocols. A quick example of a presentation protocol would be something like JPEGs, where you have a file format, for example, a JPEG, which is an image file format. But then we have the top layer, which is the application layer, and those are the actual applications themselves that run in our environment. So in terms of working with networking, and if you're doing anything with the Cisco Networking Academy, CCNA Study Prep, Network Plus Study Prep, you're going to focus more on the bottom 4 layers of the OSI model, because that's where our network devices are. And in fact, a lot of times what will end up happening is we sort of will use protocols, or we'll use networking protocols that kind of take those 3 top layers and kind of make them an application layer by themselves. But we're going to talk about these in a pure OSI format, and we're going to talk about them sort of how they each work. Tonight, we're going to spend some time just talking about each of these, what they are, and then in subsequent live streams, as we get into more detail on how networks work, we're going to go into some of these in quite a lot of detail. So this is a really important lesson or live stream for you, or video, depending on when you come into it. It's very important for you to understand this, because if I say something to you like a router, you can say, oh, a router, it communicates between 2 networks. It's a layer 3 network device. And I say, oh, here's a switch that works with frames. And you'll say, oh, a frame is something that occurs in the data link layer. A switch is a layer 2 device. And that's the language that people use in industry. So they'll say something like, I have a layer 3 switch. And you have to go in your head and you have to say, well, let me think. A switch works with frames, and that's layer 2. But a router works with networks, and that's layer 3. So what's a layer 3 switch? It's a device that allows you to do things like virtual LANs, VLANs. It's a device that allows you to do some of the network functions with a switch device. Don't be worried if all of a sudden you're like, whoa, this got pretty deep pretty fast. I'm going to spend some time unraveling all of this over the course of both tonight and subsequent live streams. So hopefully that's helping you guys out. So one of the core concepts of the OSI model is that each layer talks to a corresponding layer on another device. So here I have 2 devices represented by, I have device A, we'll call it host A, or it could be computer A, it could be device A, and I have host B. And that could be, again, computer, could be a device of some sort. Now, what's interesting, and let me just show you a few different types of end devices that we have here. I'm just going to grab another screen. Let's take the whiteboard off here, and we'll add another camera. Back in the stream. So I just got the note that the audio was off. So hopefully it's back here. We'll find out if you guys say anything, or if when I'm watching the video. So this is an endpoint device. This is a physical device. It has physical connectors that allow me to connect up to a network. You could have small devices. That one happens to be a little Snapdragon board for doing cell phone development. Here, for example, is a debug board. So this is a little debug board that I might use, or that's not the debug board, sorry, this here is actually an MX chip. So this is being used for cloud services and such. So I can use this for doing different types of cloud stuff. So this is a little cloud board that I might have here. And I'm just going to go in here, bring that back up. And then I could have, another device here, like this is the debug board that I might have, little debug board. What's this? What are all these different devices? Well, I think sometimes when we're working with computers and networks, we kind of have this sense that every end device that we're going to use is going to be a computer. And that's not often the case. A lot of times those end devices could be some of the devices like I've just shown you here. Let's go back to the whiteboard. So this is where things like networking really come into play, because if you're going to be doing anything with networking in the modern world, so to speak, you're going to be working a lot with IoT devices like the ones I showed you, where you might have something like, this card might be in one form or another embedded into another system so that it can communicate with a collecting device. So this might be part of an industrial plant. So you might have an IoT, an internet connected device that's part of a petrol plant, like a refinery, or it could be part of a sawmill, or it could be part of something where this is now connected through a network that you're going to build, because you're going to be so smart after doing these live streams. And this device is going to communicate to a cloud service. It's going to collect data on maybe, let's take the sawmill, how many board feet that we're cutting in a certain period of time, all done on a network. So that's why so much demand is being placed on people with network skills, people that are going to be like you. So if I have a look at how things work, I have this physical environment down here, and this physical layer is going to connect to the physical layer of the other device. So if I have something like a physical little controller here, it has a port, and that port connects maybe through a wire, maybe through wireless, through some methodology. It physically connects to a receiver, transmit to receive, and we refer to that as a peer-to-peer connection. So the physical layer talks to the physical layer of the other device. And then what happens is, and I'll just use host B here as the example here, is that it will pass that physical to the next layer, which is the data link. And the data link is going to be a protocol that is understood by both sides of the communication. Now, when it comes to these lower layers, they have specific names that we use. So at the physical layer, what we have are bits that are transmitted. So we have little tiny bits that are transmitted, on and off signals, signal, no signal, light, no light. If you watched the previous live stream on subnetting, I talked about binary and how computers will have a on, off, a yes, no, a 1, or a 0. So what this is I'm sending a physical signal, which is going to be the same thing, a 1, a 0, and whether I'm doing that wireless or whether I'm doing that through a copper cable or a fiber cable, I'm still having a way of sending ones and zeros, sending bits. But when I get a bunch of bits, if I just give you a ones and zeros, you have to have a way of knowing where does that begin and where does that end in terms of a discrete unit of communication called a frame. So what we have is we have a frame. And you may have heard the term Ethernet before. Now, without going into a lot of detail, because it's not really completely appropriate at this point in time, but there are different types of Ethernet frames. But when we're dealing with Ethernet, that's a frame type. But it's only one of many different frame types that we can have in the world. But that's the one that's most commonly used, especially if we're networking computers together. And like I say, most computers nowadays run a protocol called the TCP/IP protocol. And the reason that a lot of computers run the TCP/IP protocol is because the internet runs the TCP/IP protocol. So it's a very popular protocol. But the frame tells me what is a discrete set of ones and zeros, right? And then above that, at the network layer, what we have is we have something called a packet, okay? And the packet is a way of taking a series of frames and putting them into a conversation. Now, it's kind of tricky here because the transport layer is called segments, So we have segments which define the communication. So I'll put segments in there. Whoop, dropped my pen. So we have segments in there. And those segments are, often packets and segments have a pretty tight integration. And that's why one of the more popular protocols out there that we have is the TCP IP protocol. And what it is, it's the transport control protocol, which is the transport layer, IP, which is the network layer. So the next time somebody says TCP IP, you can say, oh, that relates to two layers of the OSI model. It relates to segmentation and it relates to the network. So the IP identifies the network entity, the host, the network, and the TCP handles the transmission control so that I know that this machine's talking to this machine. Now, I hope that I'm not getting too deep in the woods or too confusing at this point. Like many things, when we're learning something new, sometimes we're swimming a little bit before it starts to make sense. And remember, you can always watch this video again, and you can always ask questions. And even if you ask questions later on, I'm going to, I'll look at the comments that are put in there. So a way of remembering these four lower layers is the classic example is some people fight back. And the other ones you could say, you can go whatever mnemonic works for you. But a lot of ones is some people fight back. Now, on the other end, when I'm communicating, it's the same thing, right? So you have segments, you have packets, you have the frames, and you have the bits. So what happens is if I'm communicating and I have an application, so let's say I have an application like Notepad, and then what it does is it creates a text file. And then what it does is it establishes a session connection, right? That session connection is going to be put into segments. Those segments are going to be comprised of packets. Those packets are going to be put into frames. Those frames are going to be converted into signals, bits, ones and zeros. Those ones and zeros are going to be sent to the destination. Those ones and zeros are going to be torn apart and say, oh, here's the frame, and it matches, we can talk. Oh, here's the network. It's a valid network, we can talk. Then it goes to the segments. This is part of this conversation. Then it goes up to the session. This is part of this session that we're having. Then it goes to the presentation. It's a text file. And then the application on the other end could be maybe Word. So even though my application in host 1 is Notepad, it goes all the way down to the network layer, gets transmitted through the entire network, and then gets transmitted up to the application layer. And this is referred to as peer communication. So what we're doing is, and that's spelled P-E-E-R, just in case my pronunciation isn't very well received. So that's P-E-E-R, and peer communication, one communicating with another. I just have it's frozen a little bit here on my screen here, so let's go there. So peer communication says, and let me grab another colored pen here. You'll as we do more of these sessions, you're going to know that I love to use different colored pens quite a lot. So peer-to-peer communication through the physical. Data link talks to data link. Network talks to network. Transport talks to transport. Session talks to session. Presentation talks to presentation. Application talks to application. So the logical way, or the way that they communicate, is peer-to-peer. But you can't just go from transport to transport. You have to go down all the way from transport to network to data link to signal, signal across to data link to network to session. Right? I always say session. Network to transport. So it's always a peer-to-peer communication. Bits talk to bits at the very basic level, but the data frames have to match. The type of network, it has to be a valid network matching in terms of addressing and in terms of permissions. It has to be, the right segment, and it has to be the right applications and such. This is sort of just a one-to-one type, but a lot of times what we're going to do is go through network devices. So if I go over here and we take a look at the OSI model, a lot of times what will happen is we will have multiple segments here. I have to draw this out quickly. Did I get 7 of them? I have a little bit of a lag. I'm not sure how it is on your side. Let me clean this up a little bit. And I'll get this cleaned up for subsequent sessions. You know what? I'm going to try something just super quick here to see if this is going to work for me. I'm going to grab this here. A little bit of troubleshooting live. We'll see if it recognizes this device here, because this is a better device for me. No, it's not going to. It's my tablet, for some reason, has decided to be uncooperative at the most inopportune time. I will go and talk to Wacom and see what's going on. I'll fix it. Okay, so if we go in here, we have these layers in here. Okay. Okay, 1, 2, 3, 4, 5, 6, 7. So what normally will happen is you will have some, users. Users don't use networks. They use applications that use networks, right? So there's not like a user is going to sit there with, it's not like we have keyboards that have a 0 and a 1 on it and users are tapping zeros and ones. Obviously, that's not going to work out too well. So the user will use an application and we're going to set up the network. But a lot of times it'll go and then it'll go to another device, but that device will just bring it up one layer. Then it'll bring it across one layer, bring it down to one layer, and continue the bit pattern so that it is communicating across the different devices we have. So if it's a layer 2 device, this would be a switch. So a good example here is I have an application, I'm plugged into a switch. The bits are sent to the port on the switch. It goes up to the data link layer. It determines what data link it's going to do, what frame it's going to work with, sends it to another port on the switch, brings it down to the exit of that port into bits, sends it along its way. Then maybe it goes up to another switch that's connected to a router. That router makes a routing decision. After the routing decision is made, it then brings it out of that port, into that data frame, and then it puts it out to the physical bits, and then it goes up to some other device that we have on the network, maybe up all the way up. We'll just do this all the way up to the application layer, right? So what's happening here is these devices, for example, this here is a switch, right? It's a layer 2 device. This device here is a router. It's a layer 3 device. And what we need to learn as we work with different types of devices is how do we physically connect things together? How do we work with layer 1? Then we have to learn, how do I make data frames work where they need to work? How do I work with switches? Then we need to learn, how do I distinguish between different networks? How do I work with a router? And generally speaking, that's sort of where a network technician lives, in those bottom 3, 4 layers that we have. Normally we'll have IT to support. IT support will handle things like the top 3 layers. We often bundle those all together and we refer to that as the application element of our network. And this is where we're not using the OSI model. We're really sort of saying, okay, everything above layer 4 is really kind of application centric, and everything below it is where we have, the routers, the switches, and the physical cabling or the wireless networks or whatever that we're doing as network technicians, right? Now, I'm not sure how many people, I know people sort of pop in and out, but if you do have any questions or need any clarification on that, let me know. I can go into more detail here. But what I'm hoping that you took away right with this is that the idea that we have a layered approach and that each layer communicates with its peer layer. So physical communicates with physical. It's easiest to understand. That's the concept of transmit and receive. I generate a bunch of ones and zeros. You receive a bunch of ones and zeros. But the second layer above that, what do you do with the ones and zeros? That's the data frame. So that's where we have things like Ethernet, which is probably the most common layer 2 that you're going to see, but it's not the only layer 2 that we have out there. The internet has made things such that really running TCP/IP on Ethernet is a very common thing, right? Or running TCP/IP on a wireless network, which does an Ethernet style frame. Very common. However, there are literally dozens and dozens of different protocols out there, some which are very unique, some of which have languished, some of which are unique to certain devices. So this might have a unique protocol that allows this particular board to communicate with a peer board using some sort of bit pattern. It has to use physical. So maybe this one is connected up to a wireless node, and it sends out a bunch of ones and zeros. But when it hits layer 2, maybe it's its own different protocol that it's using. That can be a way of dealing with some security issues as well, because obviously, the TCP/IP is pretty popular, and a lot of devices are connected into TCP/IP networks. But if you look at industrial controls, for example, they may use other things like SCADA, right? So there's different things out there. That's why the OSI model is so important for us to have this foundational understanding of the idea that it has this peer-to-peer communication. So that's the idea behind the OSI model. And if we take a look, what lives at each layer of the OSI model? Well, at layer 1, I've been on this for a bit. This is my physical. This is where I have things like cables. And when we think physical, the first thing that comes to mind is a cable. So we think of different types of cables like fiber cables, Cat5 cables, thick net, thin net, that's why I have gray hair. That's a long time ago. But we used to have a coaxial cable, and we used to actually build local area networks on thin net and thick net. But there's only so much. You don't have to learn the history of computer networking. But the idea is that there's different ways that we can physically wire things up. A very common thing that we do nowadays, which can be a little confusing, is we use wireless networks. But wireless networks still have that physical component, right? What we have to have is you have to have a special wireless adapter card built into the device that can transmit and receive ones and zeros through the air, right? So we have to be able to transmit those ones and zeros through the air. It's not going to be, you're not going to look up and see a bunch of ones and zeros. That'd be pretty cool if you did. And unless you're watching like some show like The Matrix, you'll see a bunch of ones and zeros there. But the reality is that I'm sending signal, no signal, and my receiver can understand the signal, no signal. Now, it could be that we've already gone up the stack a little bit and we've authenticated, or we've gone up the stack a little bit and we've encrypted. But that's why you can go around and do things like what they call war driving, where you actually take a sniffer and you can sniff the air for the ones and zeros to see if you can grab some of them. We'll do security in a future one as well, right? So that physical communication is layer 1. I'm not going to do the peer network here. We'll leave that one. And then data framing, again, quite often we're doing Ethernet. We're doing an Ethernet frame type. And we're going to talk, each of these is going to be a different live stream where we go through each layer in order to learn networking. And if you look at something like the Network Plus or the CCNA, your first lesson is always going to generally be on the OSI model and what a network is. This way, when I start talking to you about a network adapter card, I'm going to be able to say that this is a network adapter card. It's an Ethernet network adapter card, and I'm installing the TCP/IP protocol on an operating system to control that network adapter card. Hopefully, it's starting to make sense to you if you're not familiar with this and you're saying, wait a second, that's a physical device that has a physical connector, or it's a wireless device that has a wireless, it can do ones and zeros. And wait a second, it has a certain frame that it can create and understand, data link. And wait a second, you installed an operating system protocol, TCP/IP, that will allow me to form the segments and the packets. Some people fight back. Network adapter card. So the idea is that at the data link, that's where we're going to have the frames. So these are my bits. And at here I'm going to have my frame type in here. And my frame type can be, there's different types of frame types I can have. Let's see if that catches up. Oh, come on, little board. It's a little bit laggy because of the move that I've had to make to a different way of doing things. There we go. So we have the frame, we have the bits, right? And that's my data link. Okay, and so the idea here is that really is the frame type that I'm going to have. And again, we're going to do an entire sort of live stream on the data link. And then we have the network, which, you know, everybody always sorts of thinks that this is networking. It's hard to, you know, convey this, but the network layer is just a small part of networking. It's a pretty important part because it's where I can logically define the network. So when I get the physical card, that's going to be built for me by the manufacturer. And then when I get the data link, that actually is going to be a frame type. It's going to be something called a MAC address, or a media access control. That's going to be burnt into the card. So if I buy an Ethernet network adapter card, I do not have control over the ports. I have control over the physical ports when I buy, but once I've bought a port, once I've bought a physical adapter card, I can't just go in and make this a bigger square. I can't change this port. This is in this case here, here's an HDMI port. Here is a USB port. I can't change that port. I bought this card with that port soldered on there, with the logic of the chipset of this board talks to that port. That's me buying it. And if it's a network adapter card, and I don't know, I think this guy has a network adapter. This is an intrinsic board. So this is for doing some electronic stuff as well. So this is a board by Intrinsic. It's it's an open queue development board. So I always have to look to see. I've got a lot of little boards hanging around. So this is an open queue development board, again, for doing things like embedded systems development. But this one here does not have a network adapter on here. So it does not have a physical network adapter, but it does have a wireless network adapter on here. So this one here has a frame on it, and this has a unique MAC address, media access control. But where I get to control things is when I install an operating system on it, and for these I'll often use Linux, but when I install an operating system on these boards, I can then install my logical numbering system. I can install my IP address scheme. And again, as we go through more of these, so will you. So those are and then a lot of time the transport is considered part of the, so we have packets here. Hopefully it catches up here. Sorry about the delay in the writing and onto the screen here. I'm going to get this resolved. Okay. And then we have our transport layer, which is our segments. Okay. Now, I know that for some of you, again, I don't know how many. It's hard because I don't have as much information or insight into how many people here are watching. But if you're still currently watching and you have any questions, fire them into the comment section and I can help you with that. Okay. What I'd like you guys to do is, now that you have sort of this very foundational understanding of the importance of the OSI model, if you want to continue on with learning about networking and such, take the OSI model, go onto the internet, grab a diagram of the OSI model, and then use that. And as we go through the subsequent different live streams, I'm going to go through layer by layer, and we're going to understand the devices that live at each layer. We're going to then look at how we can physically wire things together. That's the first thing. Then we're going to look at how we can ensure that we're using the right data frame so that we're talking the right same language. Then we're going to talk about configuring and logically coordinating a network. And we got a preview of that when we did subnetting. And then we're going to look at how to configure the devices along the way. Physical is pretty easy. You generally just plug them in. Data link is usually built into it. So our frame, we buy Ethernet to Ethernet, but switches is what we're going to learn to configure there. And then we have routers. And for routers, we have to divide into a logical network. That's where we'll do some things like the subnetting and such. Okay, so about 43 minutes. It wasn't the longest live stream. It was about 40 minutes or so. But that gives you something to work on, to understand the importance of the OSI model and how it plays into learning about networking. I hope this was useful for you. I know that A lot of times people step away from the computer or something during the live stream, maybe catch up a little bit later. I hope that I haven't scared anybody away by going through the OSI model in such depth and pulling out a whole bunch of different devices and such like that. But this will be your framework. This will be your foundation that we can then slot all of our knowledge into. So we're not done with the OSI model. We're just beginning, and it's going to be a tool that we're going to use in order for us to know what devices are doing, where they're working, and how they're navigating up and down the model and across the model. They're navigating up and down, and they're navigating across. And we're going to look at that as we look at each of those devices, from physical to data link to network to transport. And we're going to look at how we can configure the different devices and what's working at each end. Okay, guys, so thanks very much for watching. I'm going to end the broadcast now if I don't get any questions, or if anybody has any questions that they want answered right now. If you're watching this in the future, check out my other video on how to subnet. Join us next time. I think I'll do these each Sunday night for folks that want to learn about computer networking. If you're watching this after the fact, feel free to comment down below. I'll try to get any questions answered. And it should be next Sunday at 6:05 Mountain Time. We'll take a look at the physical layer of the OSI model. What are some of the devices, and what type of physical devices and physical connectors should we become familiar with if we want to learn about networking and how to connect things together? Okay, and let me know if you want. I could quickly do an overview of a small network, but we're going to build a small network at some point here as well. Okay, everybody, have a good evening, and we will see you in the next broadcast or in the comments on the channel. Thanks so much for watching, and we'll see you next time. Bye now.